This is part 2 of the Delorean alternator restoration video. If you haven't watched the first video in this series, click the link on the top right. The first video had to do with the removal and the teardown of the alternator, looking at the damage, tearing everything apart and cleaning everything out, trying to remove all the stuff that got caked in, pulling out the bearings so they could be repaired. So this is part 2, and we'll continue. We're going to start off today by just dropping the new bearings in the freezer till we need them. I carefully removed the metal sticker and left it home. I put a wire brush on the drill press here, and we're going to use that to try and clean up the aluminum a bit. Can't sandblast this part, so we can see that the oxide and the dirt is coming off, so it's cleaning up nicely. That's good enough, clean it up nice. We're going to go with this. I hit the top cover too that was done by the sandblaster just to put a bit of a shine on it, some glaze. You get that really matte finish from the sandblaster, so I wanted to even that out. You see right there. Just some quick work of that was all. Here's the staging for the first bearing. I'm going to use the old bearing as an example. I've got a 30 millimeter socket. It's just about 2 millimeters smaller than the circumference right here. So this also falls right in, so we can see this is good for fitment. We're going to go with this. And I'm adding a very light amount of lubrication to the inner race here. I just don't want it to go all when the bearing goes in. And this is the original NTN 6203 LLU bearing that I ordered for this application. None of that Chinese knockoff crap. I'm going to set the bearing in there flush. I'm going to put this on there like that. One of the reasons why I use that heavy cotton towel on the bottom there is the bottom of that race is very thin, and if you use too much force, that bearing will easily rip through the bottom of this cover. So when it starts to compress and push force against it, I could feel that towel bottom out against that metal plate, and I know I should at least stop and look and inspect. But the first time I do and take a look, I see that it's fully seated, so it's sort of an insurance policy. With the bearing installed, I use masking tape and tape up everything, preparing for clear coating. Now suspended with wire, I'm cleaning the entire part with acetone on all the surfaces that are going to be painted. And I'll be using Rust-Oleum high-temp clear coat going out to the end of the shop at the end of the parking lot. I'm not going to be recording this, obviously, with my camera to get dirty from paint and clear coat and whatnot. There it is, the first coat came out real nice. I'm going to set that to dry for about an hour while I move on to other things. I'm going to be cleaning this portion with acetone as well, using the same method, as this is also going to be clear coated. I'd left the brushes in. I'm going to have to remove them to install the bearing, obviously. This will be retaped and cleaned after the bearing is installed. Again, I add just a little bit of lubricant to the inner race. So I have an aluminum block under here to suspend the unit. So I'm putting that on the flat of the face under here. And this sits like that. And I'm using the old bearing just for measurement and testing. And for this, I have an impact socket. And this particular socket is just a couple millimeters circumference smaller. And this falls right in, leaving just a little bit of margin of room. Again, using the 6200 2Z original bearing, no Chinese crap. This bearing installation proved to be a bit more of a challenge because the race is very far down. And there's not a very good way to get a visual inspection of centering. I imagine there was a centering tool or something from the factory that went into the middle of the bearing to do this. So I had to be very careful to ensure that this stayed centered and didn't go off the side of the race and crack the outer shell. But I was able to get this after some patience and checking and rechecking to ensure everything was straight. Once I got it, I felt the seat and removed it for visual inspection, and I hit it on the first try. There we go. At this point, the case was then retaped from both sides, as we see here. I did the best I could from this side, but I'm not going to be spraying from this direction. And then I ran some baling wire through one of the screw holes to be able to suspend this for cleaning and painting. And this entire piece is then cleaned again with acetone in preparation for the clear coating. I then take it back outside and paint it. While waiting for everything to dry, I took all of these individual pieces, took them apart, put them in the sandblaster, and then put them all back together so I wouldn't lose them. I hit the ground portion of this capacitor with the wire wheel to clean this up. The plating on this bearing retainer is still good, so I left it alone. This was cleaned up in a previous video. So I'm adding blue Loctite to the 3 screws that hold in the bearing retainer, and then we're going to install this retainer now. Now I'm going to be putting in the retainer plate and the screws. Markings in the plate let me know which direction the plate is supposed to be put back into this unit. If there were no markings on this, I would have scribed something into the metal, but it wasn't necessary with this one. Tighten it just enough as the driver would let me. That's why I use Loctite. These plates set up on the press allow the shaft to go through the bottom. I have my piece of aluminum that I'll be putting on the top to protect this end. As I push this all the way to full seat on this side, I'll be dropping this down into the assembly now. While waiting on some lacquer to arrive, and as a side project for things to come, I'm building up a new mixture of nickel acetate, which I've set up in the front of the house here to vent off the hydrogen. 2 hours later, we can see it's taking on a fine blue color. I'll let that sit just a little bit longer, and then I will close this bottle and use it for the parts that I have now removed the rust from and degreased so that we could nickel plate them. And this was something I decided after I pressed these together, but this is no problem. The coating of the wires and the dried out tape with the red varnish to protect the cables and stop the tape from flaking away any further. I've removed any of the really loose tape already to expose some of the wires, and we're just going to get started with this. I admit this is massive overkill, but as part of another project, each bolt and bracket was first coated with copper, and then it's nickel plated. This is all standard electrolysis methods. It's not going to shine because it's not a shiny surface to start with. The one I wanted to come out the nicest was this main bracket, which had to be done in several directions, so we didn't have any splotchiness, and extra cleaning and detail was done for this one. With this bracket done, this is going to be the extent of electroplating in this video. I'm not going to get too involved in this. Before I start assembly, I want to talk about some lessons learned on disassembly. I would have started with a drift through here to push out that small shaft, that 9mm distance through this bearing on the bottom. That would have been a lot easier than the method that I used, obviously not knowing that at the time, right? So this shaft is a lot narrower. It's only 9mm to push that out. So tapping it lightly with a drift would have knocked that out and separated these two halves. Would have been much easier to accomplish. With those halves separated, I would have left this bearing retainer that holds it into the race in place. I would have not removed that. Instead, put this on a press just as is, supporting the bottom. I would have then pressed that shaft out from the top. From there, I could have then removed the bearing retainer and the bearing as needed, and also remove the bearing from there as required, not the way that I did it before. On this overlapping surface, I'm going to apply a light amount of anti-seize to the circumference here. Stage the press for the pressing into the first couple millimeters of the halves. The positioning is not critical for the first couple millimeters because the case can still rotate on the bearings, but I'm still keeping an eye out, being mindful of where it should be. We can see with the housing partially seated, it still spins freely. So now I'm going to remove it from the press right quick, put it back on the bench, and now I'm going to use 2 of the bolts with the bracket as a form of a guide, aligning it in the correct position so that the bracket bolt hole is lined up with the correct hole for the front of the case, so we know we have the right holes in the correct order, right? Because it would be really bad if we press this in and it wasn't lined up, it was in the wrong screw holes, then we'd have to unpress this again. So this is the correct order. They slide right in, and I know it's safe to continue pressing in now. I bring the bracket and bolts up just to align everything right, and I seat it just very lightly. And after doing so, I bring the other two bolts in, and I start putting the nuts on the other side just to get a couple of turns on the thread so the bolts don't fall back out. This will ensure everything is perfectly aligned for the rest of the seating of these two halves. At this point, I press it in the rest of the way till I feel even the slightest amount of resistance. I stop. Now I'm going to start by taking all of the slack out of the 4 bolts. I'm not going to tighten them just yet. Now I'm going to go around and tighten up each one. I'm doing it by feel, relatively tight, but I'm choking up on the ratchet, as you can see, so I can't exert too much pressure and snap a bolt. And this looks like it's spinning just fine. I want to point out that I'm going to be removing each nut and adding blue Loctite to it and tightening them. I'm going to be doing these one at a time. Putting the brushes back in now for the last time. Both screws have been coated with anti-seize before installation. I've also taken out those 2 flathead screws up top, added anti-seize, and reinstalled those too. Now we're going to plug in the connections for the new voltage regulator. Red to red, green to green. Fold the wires in properly. Seat it on there. Both screw threads are lightly coated with anti-seize before installation. Now the installation of the plastic shroud. Again, Loctite for the small screw threads. And snug this one down, not too tight as to break the shroud. Now I'm going to kick off things by sliding this bushing in up against the bearing, and then bring our slot for the woodruff up to view. Put another thin coated of anti-seize on the woodruff key. Make sure it's evenly coated, especially on the bottom there. And then I'm going to place the key into the slot on the shaft. This is then followed by the washer. The washer is keyed. The fan has been washed and dried. It's also keyed and will be placed over the woodruff key. The pulley, also keyed, is placed on the shaft in front of the fan over the woodruff key. This is followed by the washer, and then finally the nut. I'm going to secure the fan into place with a large screwdriver. Took off the nut to reapply a dab of blue Loctite and put the nut right back on before I begin the torquing procedure. And we're set up on the torque wrench for 30 foot-pounds. So we're just going to lock this nut down and call this portion of the project finished. Foolishly, I got this far. I never bothered to check the capacitor, which turned out to be bad, and they're only really available in Europe. I ordered one from England. I have to wait several days for it to arrive, so it kind of slows down the project. What are you going to do? Through the magic of video, a new capacitor instantly appears, ready for installation onto the alternator. So we'll just mount the new capacitor into place. I bent the tab slightly so it doesn't sit flush with the alternator, allows a little bit of air cooling in between. And plug in the connector. And that's it. This alternator is completely finished, looking real nice, and we're ready for the phase of installation and testing. And here's all the old parts that were removed from the alternator as part of the rebuild, including the bearings, which were ready to go. And we're back under the car, preparing to get started with installation. Put a light coat of anti-seize on the shaft of this main mounting bolt, but not the threads. Push the alternator up into the top mounts, and then I push this bolt through on the bottom just so it wouldn't fall on my face. From the top, I guide the main bolt in, and I go and slide it all the way through. And once everything's aligned, it just sort of slides in to the back and align the back and seat it into position. Pull that bolt out, get the nuts and washers ready for the next task. and just hand tighten them onto that top mount bolt. Alternator is now supported and pivots on the mount. The bolt that I used before will now go through the alternator and meet the fitting for the adjustment bracket through this other bracket. With that now in place and every bolt only hand tightened, I'm now going to turn this bolt to full seat. So when you turn it any further, it'll start exerting some tension on the belt. Fully seated now, I'm using a ratchet to set the tension of the belt. With the tension feeling acceptable at the center point, it's time to start tightening things down. We're going to start with this lower nut right here. For the one on top, I've set a pair of vice grips to hold the nut in place. This cable installs on the post by the manifold. The camera can't get back there. I actually install it last. Add our main cables to the alternator, and then we'll tie them down with the nut and the washers. This concludes the installation of the alternator. It's time to start testing now. The first test is purely mechanical, structural. Make sure there are no strange noises, nothing seizes, no parts are flying off the alternator. There are no fires, anything like that. Make sure everything sounds healthy, everything's working okay. I let this run for a couple minutes. It could run off the battery. There's no harm done. I'm still monitoring the voltage, of course. Voltage is looking real nice on the dash, though I would never trust that voltmeter. But yeah, not bad at all. This I managed to break while working on this project. This is for another video. Put on the headlights. This is with the headlights running. I should point out in fairness that at idle, this is also trying to refresh or top off a battery. So just off idle, it's hitting at 14.3 and change on the regulator and maxing out. And that's just off idle. So I'm happy with that. That's good. I'm going to throw in the hazards right quick so I can see a constantly changing load in the system. We'll run around back. And we can see a fluctuation at idle while it recharges the battery. I'm sure if I drove the car around for a while, that will clear up a bit. So I'm going to give it some gas and I'm slowly going to bring it down. And as I bring it down, I come to find that it's just off idle, that it's still at around 14.3. Just a couple hundred RPM above idle. And then that's where it tapers off. So again, that's fine. This one used to knock like 3 volts off of the meter. This is vent on 4. That's fantastic. I'm very happy with that. This is exceeded my expectations for considering it wasn't very strong alternator back in the day. I'm definitely doing the job for a rebuild. For the last test, I've shorted the cooling fan switch in the rear. Get the cooling fans to run, measure the voltage. Let the engine settle down, and we could see that it drops to around 12, 13 volts. This is with the original fans running. These are not replacement fans. So yeah, as I thought, it would probably be around there. It's a lot of current those things pull, so that's okay. Adding the headlights with the cooling fans running at full blast dropped this to around 12.2 volts. So this again is okay for this alternator. Previously would have dropped to about 8 or 9 volts at idle with these running. And you can see as I give it gas, it's charging the battery. The battery is weak because it's been running with this alternator for quite a while, constantly draining out. So replacing this battery that's at near end of life will definitely help this situation too.
Thanks for watching. Would you like to reply?